Hey guys, the objectives of this video is to look at both a normally and over consolidated example where we're going to be finding the final voids ratio. Okay, so if we've gone back to our diagram in the first video, what we're going to be doing is we're going to be going along this line here. We're going to get to our pre-consolidated stress and then we're going to go along this line here. Okay, so we're combining both the over consolidated and the normally consolidated. So this line and this line. So the way this would happen is that in the question they would give us some values like this: sigma I dash equals 20, sigma final dash equals 100, and sigma PC dash equals, say, 50. Okay, so if we were to draw this, you can see now that our pre-consolidated stress is between the initial and final, whereas in the other examples, in the first example, so in the over consolidated example, sigma PC was the maximum, so it was larger than both of them. In the previous video's example, sigma PC was smaller than both our values, but now sigma PC is between our values. Okay, so what that's going to do to our graph is from sigma I to PC, so from here to here, sigma I dash and sigma PC dash. So that is this branch here from our graph. Okay, so that is the over consolidated branch. So this is over consolidated, and now we're going to go at our PC, at our sigma PC, we're going to become normally consolidated. Okay, so this is normally consolidated until we get to our sigma final dash. Okay, so we know that for overly consolidated soil samples, we use the CR term, C subscript R, and for normally consolidated soil samples, we use C subscript C. Okay, so those are the values we're going to be using. So if we were to make up an example, let's say that our initial voids ratio was equal to 1.1. Okay, and we want to come and find this final voids ratio. So we're going to be splitting this question up, and you'll see why. I'm going to call this E subscript 1 and E subscript 2. Okay, so E subscript 2 is the final voids ratio down here. But we're first going to have to find the voids ratio E1, and then we're going to go from E1 to E2. Okay, so let's say that CR was 0.06 and CC was 0.4. Okay, the initial voids ratio is 1.1. So we know from the previous videos that we can find E1 would equal minus CR log sigma. Okay, now the final stress for this over consolidated sample is actually the pre-consolidated stress. So I hope you can see that. The final stress we reach on the over consolidated line for this example is actually the pre-consolidated stress. So this is sigma PC dash on sigma I dash plus the initial voids ratio. So this would be CR is 0.06, so minus 0.06 log of the pre-consolidated stress was 50. Okay, so 50 on the initial stress is 20. So on 20 plus the initial voids ratio, which is 1.1. Okay, so if we were to work this out, so minus 0.06 of log 50 divided 20 plus 1.1, we get 1.076. Okay, so that's the void ratio now at E1 is 1.076. Now we're going to have to find the void ratio at E2. Okay, so E2 will equal minus C subscript C, because we're now normally consolidated. We're on the normally consolidated line. So C subscript C log. Okay, the final stress is sigma F dash. So sigma F dash. The initial for our the initial stress for the normally consolidated is actually now sigma PC dash. Okay, so it's on sigma, the pre-consolidated stress, plus E1. Okay, plus the initial ratio, plus the initial voids ratio for normally consolidated is 1.1. Okay, so all I'm doing is I'm splitting up this line to this line. I hope it's not getting confusing that sigma PC dash now is the final one for this and the initial one for the normally consolidated. Okay, so if we were to plug these values in, minus CC will be minus 0.4, so minus 0.4 log sigma final dash we said was 100. Sigma pre-consolidated is 50 plus E1 we just found to be 1.076. Okay, so if I were to work this out, 100 divided 50 plus 1.076, we get 0.956. Okay, so the final voids ratio due to this situation is 0.956. Okay, so this is 0.956. So this example, once again, combines both the normally consolidated and the over consolidated, right? So we came along this line and then down this line. Okay, in the next video we're going to do the final case you guys could ever get, and based on these 4 cases you should be pretty good to do almost any question. So this example can be a bit tricky just because it combines the two. The only real confusing thing is the reason we're using sigma PC dash instead of sigma I and sigma F, and the reason is just because we've split this example up into the over consolidated and the normally consolidated, where for this over consolidated sigma I is sigma I, but sigma F is sigma PC dash, right? For this curve, the NC curve, the normally consolidated line, the initial one is actually now sigma PC dash and sigma F is sigma F. Okay, hope that helps, guys.